At AV&R, our mission is to humanize robotics. We decided to create this podcast series to help you demystify the world of robotics and discover what some of the brightest minds in the field are doing. Welcome to Robotics for All Podcasts by AV&R.
Pedro Gregorio is a specialist engineer at MDA, where he leads a team developing robotics to help manufacture space systems. When I met Pedro, it quickly became apparent that his experience goes way beyond robotics and manufacturing. During his graduate studies at McGill University, he focused on dynamically balancing legged robots. He's a prolific inventor with more than 100 international patents and has allowed his curiosity to take him many places. Pedro's technology can be found around the world in automotive, aerospace, medical, and consumer electronics products. In this conversation, Pedro shares some of his stories building the technology we use but didn't know, and what is next for the rapidly growing satellite market. Hope everyone enjoys the show. Here we go. Hi, Pedro. Thanks for joining me.
Hi, Michael. Thanks for having me today.
Oh, it's great to have you. MDA, it's been seems like some exciting times for you guys. The satellite business is changing, and I think today there's an exciting announcement.
Yeah, it definitely, space industry has definitely been exciting recently for MDA as a premier Canadian space systems provider. Today is a really big day. We've actually just completed an initial public offering, so anyone who's interested can now follow our progress, the barometer of what's going on the Toronto Stock Exchange. So we issued a bunch of shares, and that's about being able to go out and execute on our new plans. A lot of big contracts and opportunities have opened up. Things with regards to the Lunar Space Station and a Canadarm there. Stuff with regards to satellite constellations, and our own a fleet of radar mapping satellites. So there's a lot of really big, ambitious plans out there, and this puts us in a great position to go on and explore those.
Yeah, so we've been working together. We've done robotic systems together in the past, and MDA wasn't the world is changing, or the game is changing for you guys, because with all the satellites and all the space exploration happening, robotics in manufacturing is becoming a more important topic for you guys, and hence some of the exciting projects you've been working on. So maybe it'd be interesting to hear from your perspectives, what you've been busy working on, and what are some of the problems you're trying to solve at MDA with robotics and manufacturing. Now, I know you're in the world of space, the Canadarm, there's some really cool, famous things that you guys are known for. So maybe we start with manufacturing, but we're allowed to go on tangents and talk about some of the other stuff too.
Sure. So I think when everybody thinks about, anybody who knows MDA and thinks about MDA in terms of robotics, everybody always sees those famous pictures of that strike gleaming white arm with the Canadian flag and Canada on it, balanced against the blackness of space, or the blue-green marble of Earth, with an astronaut precariously balanced on the end. And that's certainly MDA Robotics. That's our space robotics division, something we've been at for a really long time, since the second shuttle mission, and over 1,000, I think 19,000 successful captures or some such on orbit. So that's MDA space robotics. But there's more to robotics than that, and even that heritage stands us in good stead. Today, my main focus at MDA, I'm on the manufacturing side, so I don't get to do sexy products that people are going to see. But what I get to do is figure out how to build the next generation of space systems efficiently, reliably, and securely. And so more and more, as the industry transforms and moves from single geosynchronous satellite, one bird fixed in the sky above the equator, moving more towards a constellation type mission, where you think of these sort of swarms or constellations of satellites buzzing overhead. It really changes the manufacturing landscape, and you have to shift from more of an artisanal quality based on the experienced fellow, hands-on, lots of time on task, to more of a a factory that wouldn't be totally unfamiliar if you were in the automotive space. So something akin to mass production, but still with the same concerns for quality and reliability, and still a lot of really highly skilled folks, but leveraging the power of robots as a tool for production.
Yeah. So do you, just to try and get a picture of like how you envision what's your goal of the future state of MDA is? Are you, when you talk about mass production, are you thinking robotic lines where people are just there monitoring things happening, or you really have the picture of robots and people working side by side? And when you talk about a tool, you're thinking more of a robot in the sense of like it's a drill for a person. So if they have to drill a hole here, they move the robot, they set it up, they teach it to perform that task, and it's reconfigurable.
Yeah, so I think people do have ideas when they think of robotic assembly lines. They think of the pictures of, dark factories or giant heavy robots and sparks flying everywhere as they weld cars. Today's manufacturing plants, at least from my perspective, aren't like that. What we do here is, a typical assembly cell might be a robot sitting on a table executing a task, and shoulder to shoulder with a human operator working next to him, or sometimes even working collaboratively. So in some cases, the robot may be holding an item in different orientations to allow for inspection, assembly, or testing. And we certainly have stations like that at MDA, where it's a mix of people working collaboratively with robots. And then we've also got some stations where it'll be more of a caged environment. And it's not caged for safety. In our cases, it's caged for reliability of testing results. A lot of what we do is communication systems. And we all remember, well, some of us remember back in the day with the rabbit ears, if you moved where you stood in the room, it affected reception. So sometimes we'll cage our robotic stations just to keep the tests pristine. But these things are inherently safe, and they do a wide range of processes. We have one station where we have one of these human scaled robots, and he'll pick things out of a bin, place them into a testing fixture, launch a test, and then while that unit's being tested, he'll come back and grab a screwdriver, pick up some screws, and assemble, the one he tested last. So these stations are really reconfigurable, a wide variety of complicated tasks. And as you say, the robots are more or less standardized. So it's sort of, you design a station, you deploy it. When you're done that, if you need to do something else later on, you can repurpose the same equipment.
So, while you're repurposing things, you coined, well, I don't know if you coined it, but you use robot as a service, and you talk about, moving from robot tech as a product to robot technique and as a process, as technology as a process. So, a lot of this stuff you're talking about, the reconfiguration, you've built a team in MDA that has tackled this, and I also have to say, satellites, go look for an example where somebody's manufacturing satellites robotically. There's probably not many great examples you can pull from. So you guys have to figure a lot of this out yourself. So what kind of process, like for companies that are trying to get their feet wet or trying to, move themselves to the next level, what type of team and what type of partners are important for that?
Sure, and I think there's probably lots of answers to the question, and it really depends on the appetite in terms of what you're trying to do. Uh, there's lots of, I mean, this level of industrial collaborative robots has really gotten a ton of popularity, I'd say, over the past 5 to 10 years, and has been a large part of the so-called onshoring of manufacturing jobs, right? Bringing these jobs that were unskilled, low labor rate overseas, and bringing them onshore, even though our labor rates are higher, leveraging the capacity of these robots to be able to manufacture close to the customer and to be able to deal with high variability and high mix production lines, which is really important now. Everybody wants access to goods, but they want them their way. The
Yeah.
whole uh, Henry Ford, you can have it any color as long as it's black, just doesn't fly today. So people have expectations of customization and variability. So these collaborative robots, they can be used and sometimes in unexpected ways to really allow a manufacturer to explore benefits. And rather than the old trope about the robot is pushing people out of their jobs and then there's unemployment, it's more that you can enable these robots with very little technical skill to take over the repetitive, low value add, more mundane tasks, and
Hmm.
then free up the operator. So you go from the guy who pushes the cart to the guy who now programs the fleet of robots. And so you're upskilling your labor force, you're multiplying your capability as a manufacturer, and that's really exciting and has shown itself to be successful. So those kinds of tasks in terms of palletizing or machine tending will get you so far, and they're relatively easy to implement at the technician level. You can literally grab these robots by the hand and program a task, lead them on, record the task, and then have them replay it. Now, the kind of stuff that we've been doing at MDA is sort of a little bit beyond that, and it does require a different skill set. So we're not at the level where you'll grab an industrial robot like a giant hydraulic Fanuc or a Kuka, the kind of thing that you might use in a car assembly line. We're still working with collaborative robots, but we're getting in there. We're programming kinematics. We're programming more complex tasks. Peg and hole, using force control, integrating vision systems, integrating them together with other tools like automated torquing tools, etc. And that requires a different level of skill. Now, as you observed, Michael, we're very fortunate at MDA. We've got, because of the kind of work we do, we've got a great skilled labor force, a lot of fantastic engineers, and we were literally able to assemble a team from within with a few key strategic hires and build a team that's able to take a task from a system level, break it down, figure out what the low hanging fruit is for automation, and then go ahead and execute. As well, we have a whole team of tooling designers for our mainline business that allows us to deploy jigs, fixtures, and other types of equipment that goes around the robot to make these stations possible. In some cases, leveraging 3D printers to get ad hoc tooling can be a really great way to learn and cut your teeth on these problems and move forward.
Yeah, for sure. In our work, we have a 3D printer here, and there isn't a day that it isn't doing something, printing some tooling or gripper or helping out in the lab somehow. So that for us, that's been a key one to iterate quickly and try different things. That's for sure.
And I really think that's key because the days of designing by waterfall and achieving a goal are long gone. Uh, we need to be far more agile than that. And
Yeah,
a lot of this stuff, as you said, is where we're really breaking new ground. I mean, yes, there are these traditional sort of monument style automation heritage from automotive, and then on the other end, there's all of this manual assembly. But in the in between space of these ad hoc, mobile, reconfigurable, collaborative workstations, especially with the quality and traceability requirements of our business, we didn't really find a good model, and we really did have to invent a lot of it in house. So some of it is bleeding edge, and you're not always going to get it right, and sometimes you have to rip stuff out. So the ability to fail fast is key. The ability to have a team who's not afraid of taking risks and trying new things is really critical to success, and we're fortunate on that front.
yeah, yeah. You can never get these things done exactly right the first time. That's for sure. Um, when we were brainstorming a little before, you talked about Industry 4.0 and digital production. So I always like to ask this. So what does that mean for you? What is Industry 4.0 for you and for MDA?
Yeah, sure. So the fourth industrial revolution is beyond robotics, right? I mean,
Yeah.
obviously everyone knows about the great old story of Jacquard and his loom and people throwing their wooden shoes into the machine because they were afraid they were going to lose their jobs. The wooden shoes being sabots, that's where we get sabotage. um, as you move forward towards the steam engine and all of the other automation, you arrive at robots, the wonderful 1990s factories, And now as you go beyond to Industry 4.0, what you're automating is not so much the physical process, but you're automating the data process. And especially for an industry like ours in space, where these are mission critical, ultra high reliability systems. I mean, when you think about launching a satellite, that satellite is launched. You've never been able to test it in its final environment. And the expectation is it's going to stay up there 15 or 18 years, working reliably 24/7 nonstop in an environment that is oscillating between minus 150 C and plus 150 C every day. It's a really extreme environment. And so reliability and traceability are cornerstones of our quality system. And so a lot of that comes down to knowing what you built, how you built it, and when you built it. Uh, Back in the day of paper, we would have our end item data package, which is the documentation package you deliver to customers with the hardware. Sometimes the paper would weigh more than the satellite.
Right. Yeah.
And so when we try and move forward and become more agile and do automation, the question is being able to make sure that you're latching all of the data about all of the production processes, the heritage of the equipment, the parts, the supplies, and everything else, and the procedures. You know, who did what, when, with which screwdriver and what adhesive, practically, and being able to monitor all of that. Now, it's exhausting to do it manually when you're building one satellite. If you're building a fleet of satellites that could be hundreds or thousands of pieces, it becomes untenable. And the only alternative is to automate the data itself. So
Hmm.
we have, I talked about the robot whose job it is to put the equipment in the test station and then assemble it. Well, the other job he's doing simultaneously is he's recording the part numbers, he's recording the serial numbers, he's recording the digital images that he's taken for inspection, he's recording the torques on all of the screws, and he's going into the ERP system and the MES system, and he's signing off assembly steps, and he's executing kitting operations, all of these things that are key for data automation. And that's really where you can hit your stride in terms of benefiting from the technology and making sure that you haven't just assembled or tested something, but that all of the paperwork has kept up and is ready to go.
Right. So from the MDA optic, the the need to track and ensure that every step of the process was done correctly and then have traceability on how it was done, that's really that was your pain point that said, you know what, there's got to be a better way to a more modern way to digitally collect all this data and automate that.
Yeah, and that's been a bit of a long it's been a long road. That is to say, we
Yeah.
started a while ago. We went from literally having, paper binders of paper with signatures and production orders and reports that would travel with hardware from station to station. I mean, this is the way space was done a while ago, and in some places still is. We actually went ahead and developed our own in-house manufacturing execution system, which we call POPS. It's a paperless
Okay.
system. And so that allows you to have the traceability of all of the instructions, all of the operations for each serial number, be able to have testing and process steps that are signed off digitally. So you can have the operator on the floor, the quality personnel at their station, the engineer at their station, all accessing and reviewing and signing and ensuring that the traceability is following along. That's something we did uh, probably almost a decade ago now, and it's been a huge benefit for us. But moving forward, it's taking it to the next step. So to the extent that you can have an automated station, whether it be an automated assembly sequence or an automated testing sequence, performing an operation, you also want that automated station to go ahead and record those transactions at the
Hmm.
same time.
Right.
So it was a pain point for us when we were doing it the old way, but it was also a revelation for us when we embarked on the automation to realize that the physical automation is typically what people see and is really sexy. You look at the robot grabbing these things, gleaming and whizzing around through space. But the real benefit comes from automating the data itself.
Okay. Okay. And once I guess to your point about iterating, you know, once the things are set up and now you're going through this kind of, you're going through a revolution in terms of the scale of space systems and satellites. So is it the system itself that's helped you, or is it just going through that change that has kind of helped the organization embrace and face the challenges that you have to adapt to?
Yeah, change management is a hugely important topic, um, because when we're bringing in systems like this and automated systems, we think about the benefits of automation and we think about the challenge of programming the robots or
Hmm.
programming the data systems. But all of this fits into a context. And MDA, I mean, MDA was involved in construction of the first satellite that the US launched and the first satellite that Canada launched. We've been building space systems for 60 years. And we have people in this building right now who've been working at MDA for 35 and 40 years.
Yeah.
Now, that's our strength, but it's also a heritage that we have to deal with. And when we bring in changes in the way of doing things, I mean, we've all heard stories in the past about people saying that's not how it's done or that's not how we do things here. And in transforming our way of doing things, there's really is an aspect of bringing people along, inspiring and enrolling people in the possibility of a new way that's different, and not necessarily better or worse, but different and importantly matched to the challenges that are coming. Because when you're building one satellite system and you've got a schedule that maybe stretches 36 months in front of you, you can do things one way. When you're faced with building a factory that's going to be producing systems for spacecraft at the rate of 2 per day, you can no longer afford to do things in the same way.
Yeah.
And you need to transform the technology, and you need to educate, transform, and bring along all of your personnel so that they can embrace the change and be a positive part of it. And that's really a challenge.
Yeah. Yeah. You know, I see it in so many places. So I've seen companies that embrace the change, and then I've seen companies where, you know, for whatever reason, that change is feared. Let's talk about automation and robotics, and you know, there's you have to have everyone on board, and the reality is, you know, right now the buzzword is onshoring and stuff like that. Even before that, the organizations that embraced automation, some of the technology, in order to better their production or their quality or their throughput and the environment for their employees. Those are the ones that survived a lot of that outsourcing that happened in the beginning. And then now that it's coming back, that change management is important. You know, I often look at there's a document, the U.S. Robotics Roadmap,
Hmm.
and they show the rate of robot adoption and also the workforce, and the two curves are going up side by side. So the more companies, and we're talking manufacturing, the more they embrace some of this technology, the more they're building a future for maintaining and growing the workforce. Now the workforce changes, and you know, the skills required. That's where you really need to take care of you know, how you implement that change and how you transition the employees and the workforce that through that.
Yeah, absolutely. And I think executed properly, onshoring goes hand in hand with upskilling, and you end up growing the pie. We talked earlier about Jacquard and his famous loom, and all of these highly skilled loom workers who were terrified of this technology stealing their jobs. And I mean, there have been times in history when that has been the case, but uh, the people at MDA, that 35 years of experience, that is our strength. And as much as some people might be tempted to say, get rid of the people and bring in robots, you can't do it and you don't want to. You need to leverage that power,
Yeah.
that creativity, that attention to detail of all of those folks. And the question is, how do you most benefit from that deep experience, and how do you enable that employee to add value in a new way and extend his reach through robotics and automation so that you are growing the pie. It's not about getting more robots and having to let go of people, but it's about getting more robots and struggling to hire enough people.
Yeah.
MDA, we've actually been on quite a growth curve, and there's a ton of new opportunity at MDA, a lot of exciting projects, and part of that is has to do with the new opportunities that we've successfully landed, and those wouldn't happen. These new space opportunities come to us because we've been preparing. We've literally been trying to think ahead and leapfrog what market wants so that we're ready when the market is.
Yeah. It reminds me, I've got an upcoming conversation with Rolls-Royce, and they're on this mission to adopt some of the AI technology that they've identified, and they developed a framework for this change management because they were given the message by their employees that if AI comes in, it's got to be done ethically and it's got to be done right. And they got, in their case, so aerospace, you're talking in the US here, it's the FAA. So they have a governing body they have to report to. So they developed it's called the Althea framework. And I'll send you a link to it. But and when it boils down, it's a framework for change management and then making sure that you're doing this change to benefit the organization as opposed to hurting it. So it's pretty interesting the way they
Sounds
thought
like
things out.
Asimov's 3 rules of robots.
Oh yeah, tell me the three. Do you know the 3 rules off the top of your head?
Off the top of my head,
Oh,
Isaac
I'm
Asimov,
challenging you.
the first rule is a robot cannot allow harm to come to a human. A robot must follow orders of a human unless that breaks rule 1. And all other rules being equal, a robot can't allow himself to be harmed. Something like
Okay.
that.
Yeah. Yeah.
But there's some sense of ethics in there as well as self-preservation.
Absolutely. And it's boiled down into 3 simple rules, right? So
Oh,
that makes it
he was
easy
a
to
genius.
follow.
He was a genius and a visionary. Yeah. Yeah, and I think people do have a tendency. There is this simplistic notion sometimes that technology is um, a amoral, not immoral, but amoral. That it's neutral. And the
Mm.
reality is that technology, whether it be a robot or a gun, is a tool, and you really need to question when you're implementing technologies, what is the right way to do it, and what are the objectives and the goals, and there's definitely a right way and a wrong way, right?
Yeah.
If you bring in a dark factory that has nothing but robots in it, well, that's a human hostile environment. I mean, it's not something that we're confronted with necessarily, but that is a potential way of doing things. But is it the best way to do things, right?
Right.
So I
Yeah.
think that's an important conversation, and as it may seem obvious when we're talking about physical robots and physical automation, but in an age of where the word robot can equally mean an automated agent like just a software program or an AI, there's a lot of really interesting stuff we've learned as a society over the past even 4 years
Yeah.
about how those things can really there can be someone pulling the strings in the background.
Yeah. And what the intent is in the beginning, it can be, I always love talking about maybe a bit about the social media and the intent of advertising and, catering to people to put products they want in front of them, and then how that can be manipulated to change the whole discourse of society and what people are talking about and kind of the mood of society too. And we're trying to get a grasp on how to handle some of those things. And although that's a much different scale
Yes.
than what we're working with in manufacturing. I think our jobs are easier, and our ethical decision framework is much more simple in
Yeah,
that case,
fortunately, we're
right?
in a bit of a walled garden here. It's
Yeah,
we have to get product out the door, we have to keep our people safe, and we have to be efficient and financially responsible. So that's enough variables to juggle some days.
absolutely, absolutely. So as I heard, you describe some of the things that you're doing at MDA, and at one point you mentioned MDA was fortunate to piece together this pretty cool team of technicians, engineers, all doing some pretty cool projects. And as I started asking you about some of the projects you had been in the past, um, tomorrow. So today we're Wednesday, the 7th of April. Tomorrow we're going to be releasing a podcast with Sean Fenst from MPO, Medical Product Outsourcing Magazine, and he gave me the overview of some of the surgical robots, right?
Right.
So when we were prepping, I loved your analogy for this, putting the Iron Man suit on these surgeons, right? That's the goal of some of these robotics. So it's robotic assisted surgery. But you have quite a deep history in some of those technologies and some technologies that we don't see so much in manufacturing yet. Maybe there's a day that it's coming, but some of the haptic technology that you're heavily involved in, you've got your name on a few patents and stuff like that. So, maybe you want to walk me through some of the different stories that you have, like with Immersion Corp and just some of the interesting systems you've seen outside of manufacturing.
Sure. Yeah. So, I mean, MDA has a very deep history in robotics, as we said, and they come at it from the space side. I personally have been extremely fortunate in my career to have been involved with fantastic people and gotten to chew on some very meaty problems in robotics. And as you say, haptics. Haptics, you can think of it as a two-way robot. So, if you think of the robot in the car plant, its job is to go to a certain spot and control its motion. And you can push on that thing all day and it's not going to react. It doesn't even know you're there. Haptics is sort of the opposite. It's the floppy robot, the robot you can shake hands with, and in some cases you can virtually shake hands with it. We once did a system at Immersion for a museum where there were two booths, and the booths were connected wirelessly with a microphone and a camera, and there was a haptic device in front of you, so you could put your finger on it and move the handle and feel an interaction with someone at the opposite end, where you were literally interacting with someone virtually across the haptic device. So Immersion is a technology company, and their technology is quite literally invisible, but has a lot of value add. So anyone who's held a telephone and typed on one of those touch screen keyboards and hears the clicks, if you pay close attention, you might actually feel the clicks of a physical keyboard, even though none is there.
Hmm.
And that's secret hidden technology. That's Immersion technology. I was fortunate enough with my team to place that technology in today. Virtually every smartphone on the planet carries our tech. But that's one aspect of haptics. The other aspect is, as you were saying, Michael, is the Iron Man surgeon. So people think of a surgeon holding a scalpel in his hand and operating, and then people hear about robotic surgery, and they might think of a robot holding a scalpel and operating. But usually that robot isn't operating autonomously. There's a surgeon behind. And
Right.
what the surgeon does to control the robot is he holds a handle, and that handle is a haptic robot. So as he moves the handle of the robot, which is shaped like the handle of a scalpel, he can go ahead and guide the robot through the cutting, the pulling, the surgery itself. At the same time, as the robot surgeon is interacting with tissue and feeling the interaction of, cutting, pulling, tearing, he's reflecting those forces back to the surgeon. So even though the surgeon is separated from the patient, he could be sitting comfortably in a chair across the room rather than hunched over uncomfortably for hours, or he could be a telesurgeon where he's remotely connected across a data link. The surgeon still feels the patient under the scalpel. And this technology is well, it's nothing short of miraculous. And I had the opportunity throughout my career, initially as a robotics researcher at McGill, later working at the Canadian Space Agency, and then through my career, more than a decade at Immersion, to work on many of these systems.
Hmm.
One system in particular that comes to mind, we developed as a surgery simulator. So the surgery would hold the handle and he'd execute a surgery, but he would be practicing. And so what he's actually interacting with is a virtual reality simulation where he sees on
Okay.
the screen the cartoon of the patient, but he feels the interactions and he can act on the patient and he can gain and acquire skills and be rated on those. So that was a product line that we developed. A little later, that technology was actually licensed to a company out of Italy that was developing a robotic surgeon and needed a surgeon control station. So today, that system is called Senhance, and I believe Ascensus Technology markets that. And there are more than 15 countries around the world where you can walk into an operating theater and see a surgeon seated comfortably in a chair, wearing 3D goggles, looking at a stereo screen image of an operating field. And just behind him in the operating room, there's a patient on a table. And hunched over the patient will be 2 or 3 robot arms that are doing the surgery. And he's holding in his hand this robot station that he's interacting with and operating on the patient. And I'm very proud to say that my team at Immersion developed that station. And
Yeah.
we've got a few patents on it. That was an incredible ride and is by far, I would say, the most challenging engineering development of my career, and also in many ways the most rewarding.
Yeah, I'm trying to think of how, we could use some of that stuff because in your training situation, and I don't know how much you can get into some of the details here, but, I'm imagining that when you're wearing this technology and you're working through this training, there's many different situations that you can come up against. It's probably more than just playing back all the force schedules that could happen. I don't know, maybe you could walk me through a little bit about, how does the skeleton, or what's the sketch of what's going on in that scenario of a training system?
Sure. So when you think about the simulation, you're going to think about what you're seeing on the screen, right? So there's a
Mm,
3D model,
yeah,
and the model is quite sophisticated because it's modeling soft tissue. So it has to react when you poke it or when you cut it. Very complicated. But beyond the physical representation, there's an actual physics-based engine that will calculate for every
okay,
unplanned interaction, how is the model feeding back against you. And it's not something that you can pre-calculate and put into a table. It's
right,
something that has to be calculated real time as a physics-based interaction. There's an entire science around that of haptic simulation. It's fiendishly complex and can get quite unstable, but there's some really good ways of doing that.
hmm,
So that's the training side of it. When it comes to the operating theater side, where you're now interacting with something physical, it's an entirely different challenge. There, it's about being able to sense what the scalpel is feeling, to literally capture those forces and interactions with some sorts of sensors. And then you got to process it, right?
yeah,
Because the straightforward thing is just reflect back exactly, but that may not be the best value add. There might be some things that you're feeling that are, getting in the way, noise that are drowning out what you're trying to do. So maybe you want to filter some of those, enhance some of the important signals, reflect them back, amplified to the surgeon, so he feels what's important as a loud signal that he can react to. In the
right,
other direction, maybe the surgeon is tired or has had a bad day or has slight tremor in his hand. So you can do things like remove the tremor so that the motions of the scalpel at the patient site are smooth and graceful. You can do things like motion and force scaling. So if you have a very, very small area to operate on, you can literally zoom in so that the forces you're feeling are amplified and the motions that you're executing are scaled down. So there's a whole world of possibilities around
hmm,
this technology as an enabler. Again, the Iron Man suit.
yeah, yeah. And I'm thinking, so a lot of our work, we spend a lot of time looking at let's say in the finishing world, we spend a lot of time looking at a manual process, and then we say, okay, how does that translate into a robotic system? So sometimes you want to go from a blank sheet of paper. Other times you want to grab clues from what they're doing in order to understand the way the material's reacting, maybe there's some clues with the abrasives they're using, the type of finish they're getting. Um, so, and we're always looking for ways to shorten that turnaround time to be able to teach those parts quicker. Using 3D models is one avenue, and you can simulate the robot paths really nicely. But when it comes to the touch and what happens when that robot touches. It's different than a person, and you can do different things, but that simulation portion is still missing. So maybe there's some clues in the haptics world that could close that loop.
Yeah, and haptics, absent all of the technology, haptics, just as the human perception of touch is such a vast and fascinating field.
Hmm.
For example, texture. It's something that surrounds us, right? And you think of
Right.
texture. When you think of all of our other senses, smell, sight, sound, these are what I call passive senses. I mean, sure, you can sweep your eyes across a scene, but you're not interacting with the scene, you're scanning it. With haptics, you're simultaneously sensing and acting on the world. If you put your finger on a surface, you don't know what the texture is. You literally have to glide across the surface to detect texture.
Hmm.
And so it's literally a bi-directional sensation. And you cannot sense the world through touch without interacting with the world. And so it makes it, on the one hand, magical from a perceptive point of view, but computationally, it's fiendishly complex. Designing a haptics robot is a completely different set of parameters than designing a one-way robot that's acting on the world. We have a concept called structural transparency, because you want to feel the data. You don't want to feel the weight, the sluggishness, the resistance, the friction of the robot. That needs to be abstracted away. And there's a whole specific way of designing those tools to make that happen.
Hmm. Yeah, it's more than just a video gaming physics engine. This is a real specific simulation and how do you say, discipline that's probably a few steps beyond that. What some of the video gaming guys are getting pretty crazy with some of the gravity and some realistic scenarios. This is going to the level of where you're simulating the touch and the way that you sense the different textures and that type of stuff.
Yeah, and as an analogy, I used back when I spent a lot of time trying to explain haptics to people in my past life, I used to talk about the Japanese overdubbing film problem, right? You're
Okay.
watching the movie, and it was originally recorded in Japanese, and it's been overdubbed, and you hear the dialogue, and then you see the lips move, and there's a delay, right? So and that's jarring, right?
Mhm.
There's a threshold of how much time between the moving of the lips and the syncing of the sound before you perceive it. And that's based with the auditory system and the vision system, which are really quite slow. But the haptic sense is immediate. And if you're more than, say, I don't know, something like 30 milliseconds off,
Hmm.
the haptic illusion gets broken. And so
Okay.
any haptic system, which is a full real time sense, react, sense, compute, react, sense, compute, react, that whole system has to be extremely finely tuned, typically on the thin edge of instability, such that you can detect a good haptic system from a bad one based on how far you can push it before it goes unstable and starts to oscillate. Or if you cop out and you're doing too much filtering on your data or calculating too slowly, things feel like sluggish, like molasses. And so you really get the sense it's sort of like uh, a violin, which is very responsive and immediate, as opposed to trying to have thick gloves on your hand and do some task.
Right. So how big is the haptics community? Is there open source projects around it? Is it a is it kind of is it a rich community?
The haptics community has a lot of variety, and there's a
Yeah.
ton of research ongoing, and there are quite a few companies involved in haptics. I mean,
Mm.
haptics, the way we do it, was sort of a novel thing. But I mean, when you think of, I don't know, someone designing an automotive interior, they're haptics experts, right? When I design how that switch feels under my hand, the weight of a shifter, the resistance, you can tell when you're driving a German car versus a Japanese car just by the crispness, the weight of the door, how it
Yeah.
slams, the feel of the leather, the texture. All of that is one side of haptics. But the stuff we were doing, what I call synthetic haptics or haptic simulation, that's still quite a vast area. A lot of experts around the world, a few companies. Some people focus on texture and reflecting texture for a touchscreen. Some people focus on doing the full robotic interactive stuff, stuff that Immersion was involved in. We did products for automotive. You know, Immersion did the first haptic control knob inside of a BMW, where you would have the screen, and if you had 5 selections, your knob would go click, 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 click with 5 clicks. And if you went to a menu where there were 10 selections, well, all of a sudden you'd have 10 clicks available, or it might feel different. The clicks could be heavier or lighter, etc. So it is quite a wide field. The challenge with haptics is that you don't get the credit, but you get all the blame, right? Because it's an invisible thing.
Right.
So, you know, when it's done really, really well, you don't notice it. And I
Yeah.
imagine many of the folks listening to this today, you know, they'll hear me say that their keyboard on their phone has haptics, and they'll think I'm just spewing nonsense or making it up. But it's there, and when it's done right, you don't feel it. But when it's done wrong, it's awful.
Yeah.
Or sometimes, you know, like on the BMW example, which was literally bleeding edge technology, was ahead of its time and was overly complicated, people blamed the haptics, even though the problem wasn't the haptics, it was the user interface implementation that was quite challenging and not accessible for the average car buyer. So it's a challenge. But I would say that it's haptics has a high value add, but it's challenging to find an application where haptics alone has a value, because it reinforces other senses.
Gotcha. Yeah. Yeah. And I'm guessing that, you know, going back to MDA and the space topic, haptics plays a big role in a lot of these space missions. And I'm assuming that it was involved in the Canadarm and some of those tech. Am I right in that assumption?
Yeah, I think force feedback
Okay.
has been involved in a lot of these telerobotics operations for a long time,
Yeah.
but not always at the sophistication or the leading edge of what modern haptics is. Surprisingly, for the Canadarm, a lot of that is done visually. And I remember sitting across the table from Steve McLean and Julie Payette talking about potential haptic enhancements for the controller for the Canadarm on the space station. These were, you know, fun conversations, not necessarily in a context of getting a technology into into the place. But astronauts train extensively, and anything that changes their experience is really looked on with great suspicion. And anything that takes control away from an astronaut is quite frowned upon.
Okay.
So and generally space technology, we think of space as leading edge and pushing the envelope, and they're certainly in one dimension. Space really is a new frontier with a lot of novelty and a lot of opportunity. But in terms of space technology and flying new technologies, there's an extreme level of conservatism in the space
Yeah.
industry, which is necessary. You can't afford a failure. If you've invested $1 billion in a space mission and you tried something new and it doesn't work out, you got a bit of egg on your face. So that's why now at MDA, what we're doing a lot of, and we do have a lot of innovative space products and flying new technologies. We've done a lot of that stuff. But a lot of what I try to do day to day is innovate in the background, innovate on the process side.
Yeah.
So I'm not designing robots as a product, but as you've said, I'm using robots as a service to enhance what we do so that we can make what we do better, safer, more reliable, and more predictable.
Yeah. Yeah. You know, from your background, you're no stranger to feedback systems. So, you know, in our robotic cells, we often use like a laser scanner, or we use force feedback all the time to give the robot that little bit of intelligence to accommodate for variations in a part, or different manufacturing differences that happen part to part. So I'm assuming, you know, that's your background and that seems to be your wheelhouse. How much of that has played a key role in some of the systems you built at MDA? Is that feedback loop, is that important for the types of systems that you guys are building in your manufacturing?
So I think a systems level approach is key to success in almost any endeavor with robotics. And yes, a lot of my background, as you say, has been in haptics, which is about very intimate force feedback and closing that loop. Today, in my job at MDA in assembling space systems, what we do is we close the loop through laser trackers. So when I'm executing an assembly step, that's a precision assembly where I need to, I'll have I don't know, an antenna that maybe is 5 meters across, and I have to place a component within fractions of a millimeter and assemble it there. The way we do that is very often we'll employ robots to help us accurately position, not just in position, but in rotation, these
Hmm.
components, and then allow our highly skilled assemblers to put them in place. And we have systems that we've developed here that we use every day where we'll use laser trackers, advanced metrology systems that literally shoot lasers across the room and measure position, calculate displacements, and then feed that back to the robots. And so over a series of moves, you can get your robot to place things with far greater accuracy and efficiency than any human or tooling system would be able to do.
Yeah.
And that's a cornerstone of the technology that MDA has developed, and it allows us to deploy systems in relatively short amount of time that where you might have 1,000 different components that have been precision machined and then installed, each one robotically positioned to ensure that overall your communication system in that case is operating at peak efficiency.
Yeah. And you talked about being able to deploy in a relatively short amount of time. So what's your benchmark right now for deploying a robot system?
So there's deploying the robot system, and then there's
Okay.
having it execute its job. So
Okay.
the technology I was talking about just now was one of the first projects when I arrived at MDA. We had bitten off a substantial challenge, and it looked like we were going to take a bath on this contract. We had 400 parts to assemble in a short time, and if we took too long, we were just going to lose our money. And we were able, together with our great team of alignment experts, technicians, tooling designers, methods agents, and engineers, we were able to develop and deploy a closed loop robotic system with some custom tooling. And we were able to move from perhaps assembling one element per day to assembling 4 elements per day. And so that was game changer. It allowed us to deliver uh, under budget and on schedule, and the project was a huge success. And and from then we continued to build on subsequent projects. I think our record recently was being able to position 20 elements per day,
Okay.
which may not sound like much, but for these kinds of systems, it's really quite remarkable. In terms of deploying a robotic station, it's something that happens, from the drawing board, conceptual stage, through to developing tooling and getting that machined, doing the assembly of the system, and then doing the fine tuning, path planning, tuning with the actual parts, and then interaction with other systems because these robots don't work alone. So these things can be long-ish projects,
Hmm.
uh, but with 3D print, our own in-house prototyping shop, in a matter of weeks, you can have something up and running depending on its level of complexity and adding value on a production line.
Yeah. Yeah. Oh, it's really amazing uh, what you guys have been able to do. Um, and the story about MDA and your story, there's a lot of really interesting things that you've come across, and I really appreciate you taking a few minutes out of your busy day here to walk us through some of the stories. And um, you know in terms of the onshoring here in Quebec, you know everybody's hopeful, especially through the pandemic. I think we've got a real challenge ahead of us here to reinvent ourselves a little bit. Quebec traditionally was a heavy aerospace uh, um, area, and through the pandemic, it's been tough on a lot of companies. And there's a lot of good pieces of advice that you give, and what you guys have done at MDA is a great example of continuous change and making sure that you're improving your manufacturing so that you can embrace these opportunities as things change. It's all, the aerospace is going to come back eventually. There's going to be other opportunities. I think in Canada, we've got a lot of work to do on some of the stuff that we've outsourced. There's some critical things we need to bring back. So there's a lot of opportunities for the companies that are open to innovate and figure out a system for managing that change. And I think you guys are a shining example of, your industry is going through a positive change right now. So you're in a great spot, but nonetheless, it is change. And you guys have embraced a lot of the modern tools to get that job done and been successful at it. So it's a really great story and you're a great example of for some companies how to approach things.
Well, thank you very much, Michael, for the opportunity to talk about it and to reminisce on some of the crazy projects that I've been involved in over time. I think, as you say, we've been through some rough times in Quebec, but we're really well placed. As a technology powerhouse, there's a lot of enthusiasm and innovation and entrepreneurial spirit here. So there's a lot of bright days ahead. I think there's lots of really great challenges, business and technical and medical. And let the world come to Quebec and let us go out, because there's a lot that we have to offer, and I think we can really make a difference. So bring it on.
Absolutely. I feel the same way. So thank you for joining me, and until our next project meeting.
Great. Thank you, Michael. Have a fantastic day.
Thanks, Pedro. You too. So this concludes the episode of Robotics for All podcast by AV&R. If you don't want to miss another single episode, don't forget to subscribe to our show in your favorite podcast app. Thank you very much, everyone, and we'll talk again soon.